There we go. So good morning, everyone. This is Mark Roberts from Red Hat, and I'm going to talk to you now for the next few minutes about something new called Red Hat Advanced Cluster Security for Kubernetes. Now, the purpose of this solution is really to enable organizations to securely build, deploy, and run cloud-native applications. And this has been the mission, really, of the organization that built this solution since its inception. You might have heard of an organization called StackRox. They've been around in the industry for a number of years. Red Hat recently acquired StackRox. I think it closed in February this year. And that is now being brought into the Red Hat portfolio as the solution called Red Hat Advanced Cluster Security for Kubernetes. And its purpose really is focused around those three words to allow us to build, deploy, and run cloud-native applications in a very secure manner. And there are a number of steps that we need to take along the way to do that, focused on those specific areas. So there's things like the trusted supply chain of assets that we bring into our organization. There's how we configure our applications to run in a cloud-native environment. And there's the underlying platform, in our case, OpenShift, upon which we run our cloud-native workload. But before we get into all of that, let's have a think about the threats that we face. Now, a number of organizations face business disruption. It's a key concern for chief security officers, for owners of businesses and operators of organizations. And the stats are quite worrying. 44% of organizations have delayed deployments due to security concerns and issues. And those are delays that are introduced late in the development process as a result of identifying security concerns that they have within the assets that they are potentially going to deploy. 94% of organizations, pretty much everybody, has experienced a security incident and had some sort of threat to deal with, or some sort of invasion of their IT assets that they've had to handle. These figures come from a State of Container and Kubernetes Security report done last year by StackRox, looking at a number of organizations who responded to that survey. Now, in terms of thinking about the reality versus the perception of where do these attacks come from, and what sort of issues are generating these security concerns and issues for an organization. And the figures here are a little bit surprising in that 12% are related directly to an external attack. So that is some actor sitting outside of your organization who is trying to gain access to your information or your IT assets for whatever purpose they might want to do. Moving on to that, from that, we have 27% is related to container image vulnerability. And that tends to be an area where a lot of people focus their attention when they are building cloud-native applications is, do these container images that we are about to deploy contain any vulnerabilities? And it remains a critical element of the assessment process we have to go through to identify whether an application is ready to deploy. Does it have some key standout vulnerability that's been identified that has a CVE report against it that some external person could use to gain access to our system? The biggest one there, and somewhat surprisingly, is 61% of the issues that organizations face related to security are resulting from misconfiguration or inappropriate information exposure. And this really relates to all of those different assets that we produce when creating a cloud-native application. The deployment definitions that we have, services, persistent volume definitions, configuration maps and secrets, all of those assets that come together that surround our container-based applications and personalize the behavior of our applications within a specific environment. How many people really are focusing on the security and the readiness of those assets to deploy an application out into production? So the Advanced Cluster Security solution from Red Hat takes a Kubernetes native approach to security, We have Kubernetes native applications that we are producing today. We have a number of tools and technologies like our CI/CD pipelines that we're producing are moving now towards being more cloud native and running as containerized assets. So it kind of makes sense to take that approach to security as well. What are the assets that we need to contain? What are the systems that we need to manage and control over time? And if we can push all of that into running on our Kubernetes native platforms, then we will lower the operating costs because our DevOps and security teams can be working on a common platform. There's no external system that we use to assess and inject information about the security configuration of the assets that we are creating. We can reduce the operational cost because everything runs on a Kubernetes platform. It will reduce the cost of the IT infrastructure that we need to support our applications over time. In fact, that's the whole reason why we move to a cloud native Kubernetes platform. And hopefully this will increase developer productivity, but the developer productivity really relies on the first phrase here, which is this approach of shifting left. Now, it's a fairly overloaded term that's been used a number of times, but really it relies on moving any activity earlier in the software development lifecycle. And by doing that, you lower the cost because any defects you find or any issues that you remediate earlier in the development lifecycle will be a factor of 10 or 100 or 1,000 lower than finding that same corresponding issue in a production environment. So if you find a spelling mistake in development, it will be very, very quick to fix. If you find that in production, you know all the hoops you have to go through to get that change pushed through, even if it's something as simple and stupid as a spelling mistake. So focus that now around security. Anything that we can do from a security perspective earlier in the life cycle will effectively engineer into the process a more secure system that we are producing. And this is the whole tenet around a DevSecOps approach. Now, Max just did a great job talking about biz DevOps. And I think that, there's a huge amount of sense in everything he just said. And you can then layer onto that, what happens if we want to make our applications more secure? Now, if you're building a chair, you don't build a chair and then look at it on the ground and think, right, now how do I make this a quality chair now that I've made it? You think about that at the beginning. You design in quality into a chair that you make. Use quality materials and fittings, and you'll engineer it in a way that it does the job and it's a comfortable chair to use. Same thing applies here. We don't want to develop applications and then think, right, let's put a layer of security on now. How do we make it secure? That doesn't work. We have to engineer in security from the beginning, moving it to the left. Now, this cloud security posture management is really what this advanced cluster security solution will offer. It will help us to manage the security posture of the platform upon which our applications run. And we will look at that platform in detail and identify any issues that occur. Cloud Workload Protection Platform is really where we look at how we are managing the workloads that we run on that environment. Are those workloads coming from known and trusted sources? Are they configured appropriately? And are they behaving in the way that we expect them to do? And are they continuing to behave successfully and appropriately? Now, putting the cloud, the new solution to one side for a second, Red Hat has delivered continuous security for containers and Kubernetes for a very long time. We have the trusted content that you can take from the universal base images and other images stored within the Red Hat container registry. You bake that into your build management, your CI/CD pipeline. You are using trusted assets, and you've got a good starting point for what you do. The Red Hat OpenShift platform is extremely secure, using the underlying capabilities of Red Hat Enterprise Linux Core OS to make it a very secure platform. But we always want to do more. We want to build more into the assets now and the protection of the assets that we run on that platform. And this is where we layer in all these blue buttons down here on the bottom of this page. This is the advanced cluster security capability. Now, I'm not going to go through every single one of these today. We simply don't have time. But if you want to dig into any more of these in more detail, please let me know towards the end and we can do that in another session. But focusing just on a few of these here, we really want to focus on vulnerability analysis. Do our container images contain any vulnerabilities? We want to assess our applications that make sure that the content we are producing is compliant with the standards and regulations that you may have in force, depending upon the type of industry in which you operate. So you may operate in a financial services industry or local government or healthcare, and that will cause implications for how you are assessed and how you assess the applications that you produce. And thinking about things like runtime behavioral analysis. How are our applications behaving? What are the patterns of connectivity that those applications will produce over time? And how do we spot the anomalies in that behavior and spot that an application is behaving inappropriately? Now, to give you a view of how these things fit in, I want to focus in on three very simple phases. Should we build it? Should we deploy it? Should we run it? And that's what I want to do, building out this picture here. So on the left, we have our development cluster. And we are taking in container images from the top there. We are injecting source code from a Git repository. And that will go through a build process, a CI/CD pipeline of some sort to produce an image that we will potentially want to use. And obviously, it will go through a number of testing phases on its way through to the production cluster on the right-hand side. But we're going to store our image in our image repository in the center of the screen. And then from there, we will deploy that into a production environment, taking configuration data such as deployment configurations, secrets, configuration maps, services, routes, and all of those configuration information that come together to deploy the application to produce something that our users can interact with. So our first question is, well, should we build it? And this is where advanced cluster security vulnerability scanning will come in to help us to identify whether or not we should actually build this application. Now, image vulnerabilities is an area that's been looked at by a number of technologies, and we can work with other third-party technologies if you already have a solution in place for doing that. We can take feeds of information from other vulnerability scanning facilities as well into the ACS solution. So moving forward to, should we deploy it? Well, this is advanced cluster security, configuration management, and compliance, examining those configuration assets that will be used to personalize that application and to control how it behaves within that production cluster, within that environment. Are those assets configured correctly? Where we'll identify issues with them, we'll help organizations to correct them and suggest new content or changes that should be made to those assets to make them more secure, and then to validate that and demonstrate a posture of compliance with the regulations with which you are mandated to operate. But once we've deployed an application, is the application behaving itself? Should we continue for it to run? And if we look at the diagram on the right, we have our users there on the left interacting with this microservice-based application. It's running on our production cluster. And that will interact with external systems. It might be pulling in weather information, news feeds, purchasing information for your organization, and so on. Lots of different feeds of information that will come in. But is that application reaching out to some dubious system? Is it potentially sharing data or giving out data to an organization or to a system that it shouldn't interact with? And what about all of those alerts? Our applications generate large numbers of alerts, and this is where it's difficult often to see the wood for the trees. But if we inject those into Red Hat Advanced Cluster Security, we can do risk profile management to focus where we need our time and attention. And that will allow us to filter out the noise of things that are just alerts that we don't necessarily need to focus on right now, but it will bubble to the surface the things that are really critical, will help us to look at the top 3 things that we need to focus on right now, where our application is behaving incorrectly, where we are sharing information that we shouldn't, and so on. Bubbling to the top the things that need our attention. Now, network segmentation is a really critical area for our applications. It's a conversation I have with customers on a regular basis, is how do we make sure that our applications are operating in a pillar of independence and they are not interacting with other parts of our microservice-based applications that operate on the same cluster. Well, the network segmentation will identify that. We have diagrams that are produced by the application that will call out the network connectivity and the network interaction that takes place to show you visually what's happening. But it will also help you to build out your network policies to protect the applications in the way that is appropriate for you. So to summarize, Red Hat Advanced Cluster Security for Kubernetes will help you to build, deploy, and run securely your applications with confidence. We have a policy engine in which you can create the policies that you want to define. We have starters to get you going on that based on the types of industries that you are in, the types of compliance that you need to generate and demonstrate. And it can interact with a variety of different entities that are shown on the bottom of the screen there. So we recognize that you will use other solutions for things like your log automation, your notifications, your CI/CD pipeline, your registries. Some of that would be Red Hat, some of it would be other technologies. But we can work with all of those technologies to create you a complete and a seamless solution to make sure that the solutions you deploy on your Kubernetes platform are as secure as they absolutely can be. So thank you for your time. That concludes my session for today. My details are there. If anybody wants to drop me an email and have a chat about this, then please let me know. Be happy to talk to you in further detail.